Broadcasting from our studio in Boston, Solutions Review is proud to showcase Pure Storage in the Solution Spotlight, an inside look at enterprise technologies.
I'm Doug Atkinson here at Solutions Review, and welcome to the Solution Spotlight featuring Pure Storage and focused on driving a new era of enterprise data storage and management. For more than a decade, we've been covering the ever-increasing data complexity facing modern enterprises. And as we stand at the dawn of the AI revolution, there is no better time for us to present innovative solutions to help you leverage AI to unlock the full potential of your data. So today, we're bringing you an inside look at Pure Storage, a hybrid cloud storage solution that provides enterprise-grade, all-flash, block, file, and object storage. They're a leader in the Gartner Magic Quadrant for primary storage and one of the most advanced data storage platforms to manage and protect your data at scale. And joining us to walk you through the Pure Storage demo today is Melody Zacharias, Technical Evangelist Director, and Robert Alvarez, Senior Solutions Architect. Melody, Robert, thanks for being with us.
My pleasure.
Thanks for having us.
Well, I'm glad you're here. This is our first time getting to host Pure Storage for a demo day, and so I know there's a lot you want to cover, and I'm sure I'm going to have some questions at the end, so I'm going to make sure we reserve a little time for that. But Melody, I think we're going to hand it over to you now and let you take the presentation from here. I know, Robert, you're going to be participating along as well. And like I said, after a little presentation and a demo, I'll jump back in the last few minutes and we'll have a Q&A.
Great, thanks. We're going to start by introducing you to two challenges that are commonly being addressed by AI. So you can see how AI is already transforming operations in everyday situations. Then we're going to take a look at where you will encounter the challenges when implementing these great use cases. And then Robert will step in and save the day and show you how to avoid these issues and give you a demo to show you how to take it to the next level. So this is what our agenda looks like. But let's really get started. The first of two common use cases is really quant trading, a popular scenario in the financial sector. Financial analysis using semantic search and information retrieval in quantitative trading enhances data discovery and integration by leveraging natural language processing and machine learning to understand the context and meaning of financial data. This allows traders to discover relevant information more efficiently and supports real-time data integration from multiple sources. This improved algorithmic trading models benefit from semantic understanding, which enables deeper interpretation of financial news, data enrichment, which combines quantitative insights and qualitative data. Scalability and performance are achieved through distributed computing, advanced indexing techniques, caching, and reducing search latency, and accelerated trading decisions. So how does this impact your business? Well, the integrated semantic search and efficient information retrieval in quantitative trading is significant, offering a competitive advantage through informed decision-making and reduced operational costs. What does this do? It enhances your market sentiment analysis and efficient retrieval of regulatory information to improve risk management and ensuring compliance. These technologies also drive innovation and growth by providing strategic market insights and enabling development of new financial products. So this leads often to personalized services and real-time performance tracking, giving enhanced client satisfaction and retention, ultimately leading to better trading performance and client trust. So now if we move on to our next use case, because digital transformation and chatbots are really, really hot right now. Digital transformation initiatives often leverage AI to enhance customer experiences. AI-driven chatbots and virtual assistants powered by natural language processing, again, and machine learning can handle customer inquiries, provide personalized recommendations, and resolve issues in real time. These systems continuously learn from interactions, improving their responses, becoming more efficient and effective over time. By integrating AI into customer service operations, businesses can offer 24/7 support, reduce wait times, and deliver more personalized experiences. This not only boosts customer satisfaction and loyalty, but also frees up human agents to handle more complex queries, thereby increasing operational efficiency again. Companies like e-commerce or service providers have seen significant improvements in customer retention and sales by adopting this AI customer support. So various components such as model type datasets and infrastructure play crucial roles in presenting their own unique challenges. And while it's common to see a heavy emphasis on model training as the focal point of AI projects, it's just one piece of a larger puzzle. With robust data preparation and an efficient, flexible data science infrastructure, AI projects are likely to fall short. So let's dive a little deeper into these fundamental challenges and consider the surrounding enterprise of AI, specifically focusing on the data and the infrastructure. So there's various components such as model type, data sets, infrastructure. They present unique challenges, as I mentioned. So during the training phase, AI models require rapid access to large volumes of data. The storage solution must deliver fast, consistent read throughput to keep up with the demands of the model training, ensuring that data bottleneck does not impede progress. At the same time, checkpoints where we save the current state of the model at various points are occurring. So at this process, it's very write intensive. Efficient checkpoints ensure that training can be resumed quickly. In case of interruptions, preventing data loss and saving valuable time. As we talk about this, data quality requires data preparation. This phase is metadata data intensive, demanding storage solutions that can handle numerous really small read and write operations efficiently. Properly managing metadata is essential for maintaining the organization and accessibility of data. So a multi-dimensional platform to address these storage needs is vital for the smooth and efficient operation of AI systems. As AI continues to evolve, scalability and data center concerns become increasingly critical. The growth in the AI model complexity and dataset size requires scalable storage and compute solutions. Models have grown from millions to billions of parameters, and therefore the datasets required to train have increased in size from terabytes to petabytes. Data center infrastructure must scale accordingly to handle the increased load without compromising performance. The growing number of use cases across various industries implies an expansion that demands versatile infrastructure, one that's capable of supporting diverse applications from real-time data processing to large-scale batch analytics, ensuring that data center resources can flexibly adapt to these varying requirements is essential. With the increase in computational demands, rack space, power, and cooling have become significant concerns. External constraints on energy use, including the need for government approval for data center installations or expansion in certain locations, highlight the importance of maximizing efficiency in our data workloads. Enhancing efficiency can significantly reduce the overall data center footprint and minimize environmental impact. I mean, really, it's called a data center, not a network center. Ensuring seamless integration with current systems requires careful planning and execution, with a focus on future-proof to accommodate ongoing advancements in AI technology. There is often a skill gap in organizations when it comes to managing advanced AI infrastructures. Bridging this gap can require investing in training and development for current employees, as well as hiring new talent with the necessary expertise in AI and data engineering. Adopting a future-proof, simple, scalable storage platform helps to address many of these challenges. But I'll hand it over to Robert to cover the solutions for success this brings.
Thanks, Melody, for that deep dive around the challenges in infrastructure and storage as they relate to AI. Today, I'm going to walk you through the journey from developing AI models to getting them up and running in production, and discuss the challenges organizations face along the way. We're then going to talk about common AI model workloads and what is needed from a storage perspective to ensure a successful implementation. Let's start with the development phase of AI models. This is where the magic begins, but also where many of the challenges start. Models that work perfectly in the development environment encounter issues in production. Why? Because real-world data is messy. In the controlled environment of development, our data is clean and well prepared by data science and engineering teams. These data are clean to improve model performance in the development stage. However, in production, the real-world data systems capture can be noisy, incomplete, and full of outliers which can significantly impact model performance. For example, a customer support chatbot might handle well-defined queries perfectly during the testing, but struggle with slang, emojis, or typos that occur in real-world interactions with customers. Then there are challenges with scaling data too. In development, we typically train our models with a subset of data, but in production, the volume of data can be much larger, leading to scalability issues. For instance, a model trained on tens of thousands of data points might not scale well to handle millions of real-time data points without significant modifications to compute and storage resources. As more users rely on these models, sometimes a complete refactoring is needed to handle the new volume. System integration can prove challenging as well. Integrating models with existing systems can be a complex task. Models need to work seamlessly with databases, APIs, and other enterprise systems, which can introduce compatibility issues. Ensuring that models can access the right data at the right time and respond appropriately within the existing IT infrastructure is a significant challenge. And lastly, there is real-time data processing. Handling real-time data is different from batch processing. Models need to make predictions quickly and reliably in real time, which requires robust infrastructure and optimization. Now, in the production phase, we face a whole new set of challenges and requirements. And I'm going to hit on a few of the most salient points here. Ingesting data efficiently is crucial because enterprises deal with huge volumes of data every day. We need robust data pipelines and scheduling to handle this. Pipeline monitoring is all about continuously tracking the performance and health of our data and model pipelines to catch any issues early and ensure everything is functioning as expected. Security is a big one. We need to protect our data and make sure we're compliant with all regulatory requirements like GDPR or HIPAA. This involves encrypting data and controlling access tightly. Tracking accuracy is key to monitoring our model's performance over time and making sure they're delivering the results we expect. We need to set up continuous evaluation mechanisms, and periodically, we're going to need to retrain our models with new data, which helps them stay relevant in the face of challenging data patterns and trends. Efficient GPU utilization is about optimizing our use of computational resources to manage costs and performance effectively. This involves using the right hardware and making efficient use of it. And scaling is all about ensuring our solutions can handle increased loads and data volume as our needs grow. Thus, we need to design our systems to be scalable from the start. One of the most common AI workflows currently is in computer vision applications. Now I'm going to highlight the key stages, discuss some common challenges, and explain how having an all-network flash storage can improve efficiencies both in development and in production. Let's start with the ingestion phase. This is where we collect data from various sources like SaaS applications, sensors, mobile devices, and more. The goal here is to gather all relevant data that we need for our AI models. Efficient ingestion is crucial to ensure that no valuable data is missed. Once that data is ingested, it needs to be stored. We use various storage solutions like Kafka, MongoDB, SQL Server, VectorDBs, and Elasticsearch. This stage is about ensuring that our data is safely and efficiently stored for easy access and processing later. Next, we process that data. Tools like Apache Spark, Pandas, dbt, Fink, and NVIDIA Rapids come into play here. Processing involves cleaning, transforming, and preparing data for analysis, and it's a critical step to ensure our data is in the right format and quality for training models. Pure Storage's all-network flash storage can significantly enhance this stage by providing high-speed data access and reducing latency. This ensures that data is quickly available for subsequent steps. High I/O performance means faster data transformations and reducing processing times, which is crucial for timely insights and improving overall efficiency. Once our data is processed, we move to the analysis stage using tools like Jupyter, Python, and R. This analysis involves exploring the data, visualizing trends, and running initial experiments to understand what models might work best. At this point, we can now train our AI models. This is where we use the prepared data to teach our models to make predictions or decisions. Training is computationally intensive and requires a lot of resource to iterate over data and fine-tune model parameters. Finally, we reach that inference stage where our trained models make predictions or generate outputs based on new data. Inference needs to be fast and reliable, especially in real-time applications like recommendation systems, object classification, or fraud detection. A high-performance storage platform like Pure Storage reduces training times by providing rapid access to data and enabling parallel processing. This means models can be trained faster and more efficiently. For inference, low latency access to data is crucial. Network flash storage ensures that models can quickly retrieve the data they need to make real-time decisions, improving overall system performance. Lastly, we're going to get into the challenges of training and checkpointing large language models and explore the issues that arise during full training and fine-tuning. Training a full LLM from scratch is extremely resource intensive. On the other hand, fine-tuning an existing LLM is less resource demanding. It requires less computational power and a smaller dataset tailored to the specific task or domain. Fine-tuning can be done more quickly, usually within days to weeks, versus a full training can take several weeks or even months. However, both processes involve repeated data reads and frequent checkpointing, which constrains traditional storage systems. When training jobs are running, LLMs repeatedly reread data, which create a constant random read workload. This can lead to performance cliffs in many storage systems once a certain level of randomness is reached. Additionally, training jobs often write checkpoints on the model back to storage. And if multiple jobs are writing checkpoints simultaneously, it can overwhelm storage systems, especially those optimized for higher read performance. And it can result in significant slowdowns and inefficiencies. Ideally, we want to access data in a way that makes logical sense for our workflows, not just to avoid storage quirks. Similarly, coding jobs to checkpoint at logical intervals should be straightforward without worrying about overwhelming the storage system and interfering with other jobs. To address these issues, it's crucial to keep datasets on storage systems that perform well and scale predictably, regardless of the workload mix. This means using storage solutions that can handle high read and write workloads without performance degradation. We should rely on storage systems like a Pure Storage FlashBlade that can handle write workloads at scale and maintain predictable performance even as the number of training epochs or checkpoints increases. By addressing these storage-related issues, enterprises can ensure their AI systems are robust, scalable, and efficient, paving the way for a successful AI deployment. Now let's see a demo of a financial RAG application using all SEC filings from 2009 to 2024. The first step is that a user will typically see a user interface like this, where they're going to ask a question and get a model response out. Now here we're going to ask a simple question about a specific company's debt disclosures from their latest filing. Now notice here that I'm not connecting to the SEC filings database because we want to show that if there is no context, that the model won't hallucinate any data. This is very typical for models like LLMs to have guardrails around what it can show to the user. So when I run this query, it'll be fairly quick. It cannot provide any information about Xerox Corporation's debt disclosures. If it says if you have some additional information, please give it to me and it'll help in assisting. Now, what we're going to do next is actually ask the exact same query, but this time connecting to that SEC filings database that is running on KDB.ai's vector database and powered by a Pure Storage FlashBlade. This is going to take a little bit to process, so while it's doing, let's actually look at what's going on under the hood to get a better understanding of the entire workflow. Now, we're going to be using Llama 3's latest model, or Meta's latest model, Llama 3, but let's take a look at a little bit of that workflow. Now, we were just looking at that user interface. In that user interface, we typed in a query. Now, what's happening behind the hood here, when we're connecting it to that SEC filings database, it's going to check to see if there's a company name associated that it can help use to narrow down the vector database search. If a company name is present, we're going to pass that query plus that company's name to that vector DB so that it can extract the most relevant information around that specific company's filings. And if no company name is present, we're going to do an entire vector database search on all of the vectors that we have in our vector database. Now here we're using financial services data, all 10K filings from 2009 to 2024. And when we hit that KDB.AI vector database, we're actually going to get additional RAG context out. So it's going to say, here are the most relevant vectors related to your query. And we're going to then pass those to a summarizer. So basically another LLM here that is summarizing that output. The reason we want to do that is because sometimes that output may not be in chronological order. So we're going to have it summarize it first and put it in chronological order so that the final stage will then generate the proper response. Now notice here that these two in green here, the get company name and summarize outputs, are actually optional things. You don't have to do this in your LLM. You could just go straight from user interface, vector DB query, and put it through the Llama 3 with RAG. But here we're doing additional steps to highlight what might actually be happening in production, because you don't want to just throw a bunch of stuff into that large language model. You want to summarize it and clean things up and put additional guardrails. So these are sort of acting like agents in a sense. So lastly, that Llama 3 with RAG is going to have the full query plus its summary, and then it's going to return to the user interface. Now, when it comes to the Python libraries that are used, we're actually going to be looking at predominantly these 5 libraries here, where these are the only libraries that are needed to run Llama 3 with 70 billion parameters and connect to the KDB.AI interface to interact with our vector database here. There are other libraries that we use, but this is just a summary of letting you know how actually much the LLM world has progressed with tools like Hugging Face. There isn't a lot of libraries that are really needed to build these pipelines out. Now, we're actually going to define our LLM here. Here, we're actually going to, like I said, connecting to Llama 3's 70 billion parameter model that is residing on Hugging Face. We're going to create that transformer saying what we want to do here is text generation. We're going to tell it some of the additional parameters around how many, what sort of quantization do we want with our parameters here. We're using float 16 because if you use float 32, they may actually take up too much space in your GPU and you can't run any generations. And then here we're actually going to be loading the embedding model. The embedding model here is sort of the secret sauce of how do you actually filter and separate all of these information in this higher dimensional space so that, queries about soccer are in one space and queries about football are in another space. And queries about debt disclosures and 10K filings might be in another, so that when we ask a query, it actually knows what space to search for and pull those relevant contexts out. Now, for both of these, we're going to be putting it on NVIDIA A100 GPUs. And then kind of comes the cool stuff where we're going to do a little bit of prompt engineering. Now, in prompt engineering, and particularly for Llama 3, we have 2 roles that we can define. Here we have the system role, which is, you can think of that as like, what sort of hat do you want your LLM to wear? So meaning, like, for example, here we're asking it to be a helpful financial assistant. And then the user role, which is sort of to support the user's query and tell it what to do with the user's query. So notice here in this company name template, you're saying, your task is to return the name of the company being discussed and only provide the name of the company in your response, right? But then for that user role, we're saying, what is the company name being discussed in this statement? And then we pass that user's query to it. And then we return that template to be then passed on to the large language model with all of that information in there. Now, we actually have several templates here. We've got sort of the summarize the embeddings, and then the Llama prompt, the full Llama prompt that we're passing to the data. These can vary in size depending on exactly what you're doing, and prompt engineering is a hot topic here for improving large language models that we just don't have the time to dive into here. Now, how do we get our data from our KDB.AI vector database? So here we're going to be using their Python API, and here, if there is a company name present, we can actually filter to those results before doing that vector query search. So we're going to say, hey, filter to this company name, and then do that vector search. If not, like I said, we're going to grab the nearest neighbors, the top 10 nearest neighbors from our vector database, looking for nearest neighbors. And then we're going to do a little bit of parsing so that we can pass that to the model quite nicely. Now, in this helper function to call the LLM, this is going to be a helper function that we're going to use in a little bit. This is how you would just typically call the Llama 3 large language model. Here we're basically saying, look, if it's asking to do a company query, so here we're saying, like, what hat should it be wearing? Should it be the company hat, the summarize hat, or just the general text generation hat? Here saying, like, look, if it's the company search, give me 16 tokens back, right? Because we want to keep the name short and sweet for us to do a quick vector search on or a quick filtering on. Then here for the summarize, we wanted to give us some information out, but not be too lengthy. And then obviously we're going to pass those through each of those templates that we defined before. And then here, what we're doing is basically prompting those messages for the LLM. So what message are we giving it? Things like the tokenizer. These terminators are just sort of the end of sentences and like what to do with tokens that it does not recognize so that we don't get errors out. And then our output. Here we're saying we want the temperature to be 0.6. So the closer you are to 1, the more random your responses are. If the closer it is to 0, the more static or cold they are, so to speak. And there's other parameters that we can be passing here to really fine tune the output of that model. And then we're going to return that output. But we're going to be using this helper function in this generate response to our query. In this generate response, we're saying, well, if there's included context, then let's make sure we get the company name out and then get the vectors that are related to that company if name is present. If not, just look through all of the vectors that are related to that query. Then summarize those responses and then get the final response. And basically, we're going to say pass that context plus the final message here. Now, as I mentioned, we actually can be looking at what the model is giving us now. And if you notice, before it was just pretty short and sweet saying, I can't answer that question for you because I'm not provided context. But here we're actually looking at several financial metrics for Xerox Corporation. We see the total debt, long-term debt, short-term debt, interest rates, all these things that were in those filings. And then it gives us a summary of what it thinks its financial position is given that information that was passed. Now, this could be very useful for a financial analyst that is, researching a company that may just need to quickly look up, and in what better way to do so by actually providing it with RAG information using an LLM, both of those powered by a Pure Storage FlashBlade. I think this should give you a good idea of how all of this is put together. So thank you for your time.
Well, that's great. Robert, thank you very much for that demo. Melody, I have a question for you with regard to what you're seeing customers demand right now with regard to AI. I know there's a lot of buzz and there's a lot of interest, but you guys are dealing with enterprise level clients. What are you seeing with regard to their demand and what they're looking for on the AI front?
You're absolutely right. There is a huge demand in AI right now, particularly on the enterprise side. They're prepping for that demand that is coming. And that demand, a lot of it lands in data. So they need to get that data ready to be able to grow, whether they're ready to move now or they're getting ready to move in the future. So they have to land that data and get that ready to be used for AI when it's ready, whether it's now or in the future. So being ready to grow for the future or being ready to use it now and action it for the future.
Well, and I know I mentioned in my intro that that we were really kind of keen to spotlight an innovative data solution, and that organizations should really, as we're sitting here at the forefront of this, what I would consider maybe the most significant technology revolution that we will ever see. That they should be rethinking their entire data approach. I mean, are you seeing people get down to that level where they're rethinking everything from the bottom up?
Absolutely. It's very much like building a house, right? You have to build your foundation. We have those data services on top of that so that you are ready to build for your future, whatever that is. We have pieces that work together. So that whether you are structured or unstructured data, those pieces are working together so that all of your data flows. It doesn't matter what it is. And that's really key when you're going to work towards your future. You want everything to work together, right? All of those pieces of data, and you want to make sure that it is easy to use and it will conform for the future, for sustainability, for data protection, for everything that you are going to need, regardless of how it affects your data, so that you know you are totally future-proof.
Yeah, no, and I I respect the fact that everybody has got something, and starting from scratch is a big ask. So we're typically going to see people kind of working within what they already have. I know you mentioned KDB, but have you tested other vector databases in addition to KDB?
Absolutely. We work with all sorts of different vendors. Milvus is another popular one. And we work with multiples, and we have a full stack of vendors that we work with, all the way up the stack. And it doesn't matter what you're looking for. I mean, there's lots of them out there, and each of them have their own benefit, right?
When we do an event like this, oftentimes we consider it kind of the gateway drug to really finding out what's going on in a solution like this. So we would encourage everybody who's watching this event to reach out. I know there's a couple ways you can connect with Pure Storage. Certainly, there's a contact us. There's a schedule a demo, meet with an expert. What can people expect when they engage with Pure Storage? What kind of a conversation happens, and how do people typically kind of process through? Is it a proof of concept? Do they get down to a demo? Where do you see that?
Well, it depends if they're already working through a partner. So somebody like WWT, they'll go that way. But if they've never talked to us before, or if they've never engaged with us, you can talk to a chatbot, right? It's the AI way sometimes. Or just call us up and we'll get in touch and chat with you. And then that engagement, always, we love to talk to people. We're very customer centric. And then work through a POC is usually a really great way to get things done. Touch, feel, do. It's a great way to get started.
I mean, at a minimum, you're going to learn a lot about how a solution like this can help your particular situation, and at a maximum, you may end up, really revolutionizing your whole data stack. So again, for everybody out there, by all means, reach out and engage. I know questions are kind of popping in for me. One of them is, what hardware setup did you use for the demo?
Oh, well, we have this really great S500, one of my favorite units, FlashBlade S500, a lovely unit, which is a great one to use. And we even have on our website where you can just sign up for what's called a test drive. So if you wanted to check it out, you don't even have to talk to anybody. You can just go on the website and say, hey, I want to try this out. We'll send you an email, and you can check it out, see what you think, even without having to bother anybody. Sometimes those introverts, people like me, don't want to necessarily talk to anybody, but just want to try out the hardware.
Yeah, no, I'm actually just seeing that now. If you go to the resources, on the resources tab there on the Explore, you can click on Take a Test Drive, and there's a free flash array virtual lab, which is pretty cool, and you can try it and start to play around with it. Is that really at this point? I mean, we are at this threshold of even though all the data that we've accumulated in the enterprise is still amazing, we're in this moment where that seems to me like it's going to be even more exponential, if that's possible. I mean, when you think about it, is this idea of a flash approach kind of the best possible answer in terms of just raw power required to handle all this sort of thing?
Absolutely. I mean, completely, the disk is dead. I mean, you've heard our CEO say it, and he's absolutely not wrong. Disk is totally dead, and you're not going to see anything faster than Flash. Our founder is revolutionary in his thinking. We are constantly innovating, and absolutely, you're not going to find anything faster. So I can't imagine anybody is ever going to put anything on spinning disk again. We have units that will put the equivalent of archival data on flash for the same cost as disk. Have it accessible like that in the day of AI. Who knows when you're going to need that data? I was just reading the fact that internet data, what we use currently for large language models for training, is about to be completely consumed. Every organization is going to need that archival data to use for their large language models. We're running out of data. How are our AIs going to get smarter?
It's absolutely incredible, and also there's there is going to be this challenge with regard to open versus closed AI, and where these models will run, and the challenges that will bring about with regard to, again, just pure raw storage and horsepower for organizations that don't want their data intermingled into some of these larger language models that where it gets a little more complex. And I think that's all part of the strategy that folks need to start to sort out as well, is how are they going to take advantage of the AI moment while still protecting what is their proprietary data. And I got to believe that you're being asked that all the time.
Absolutely. And we're growing as a world, the amount of data, but it's not growing as fast as these models are growing and learning. And nobody knows where we're going to be in 20 years. So the more data that each organization has makes them more and more valuable. So if that data is valuable, why would you not want to have it accessible quickly and at a moment in time?
Yeah, well, again, we are always looking forward to highlighting new and innovative companies that are taking a completely different approach to things, companies that are on the leading edge. Gartner Magic Quadrant leaders like Pure Storage. Certainly worth checking out. We're very happy to have you in the spotlight, Melody. Thanks very much for the time today. And Robert as well. We appreciate it very much.
My pleasure. Thank you.
So wonderful being here. Thanks for your time.
Well, there you have it. Another solution in our spotlight. We want to thank Melody and Robert and Pure Storage for that presentation, and we appreciate your attendance as well. Until next time, I'm Doug Atkinson here at Solutions Review. Thanks for watching.
If your business would like to be featured in a future event, contact us today.